So let's take a look at this fencing. I'm going to set up the variables like this. Oops, I think I've got one extra fence in there in the middle. It was only divided in half. So let's regraph that. Here we go. And we've got it divided not in half, but we're dividing it in there. And we're letting this be x and this be y. So really there are 3 lengths of x and 2 lengths of y. So if we're going to minimize the fencing, we're going to minimize the perimeter, and the perimeter is 3x plus 2y. I want to reduce the number of variables here, and I know that a equals x times y, and the area is 1.5 times 10 to the 6th equals x times y, which means y is 1.5 times 10 to the 6th over x. So I'm just isolating y here, and now I'm going to replace my y expression in my perimeter statement. So perimeter is 3x plus 2 times 1.5 times 10 to the 6th over x. And I'm going to also make sure that I rewrite this a little bit so it's easier. So I'm not going to multiply the 2 in, so that's 3.0 times 10 to the 6th, and I'm going to write it as x to the negative 1. That just means the derivative is easier to take. So the derivative is 3 minus 3.0 times 10 to the, well, let me write that times a little bit more clearly so we don't confuse it with an x, times 10 to the 6th x to the negative 2, and now I'm going to rewrite this as a fraction. So it'll be 3x squared minus 3.0 times 10 to the 6th all over x squared. I want to find the critical points where it's equal to 0 or where the derivative does not exist. The derivative does not exist when x is 0, but we don't have to worry about that because we can't really have an x equals 0 and still have an area. That means that I'm just equating the numerator to equal 0, which means that x squared equals, moving the 3 over, 3 times 10 to the 6th over, dividing by 3, I get 1.0 times 10 to the 6th, and taking the square root of that, I get x equals 1.0 times 10 to the 6th square root, which is 1, because the square root of 1 is 1, times 10 cubed. There is, and I don't worry about the plus or minus because the minus sign makes no sense in the context of this question. So now I could put this on a number line, and we've done that in the past. What I want to show you is there's another way to do it, and that is to take the second derivative, doing the second derivative test. The second derivative is, here is my first derivative, so I'm going to take the second derivative, which will be 6 times 10 to the 6th x to the negative 3, and that is always going to be positive as long as x is positive. So it's going to be always positive, which means it's always going to be concave up, which means this point right here is a minimum. And that is the end of the problem. So if you, once you've got your x, then you can use your x to find your y value using this equation right here.